Good morning, student. Today we have question number second in exercise 2.1, and the question is by Euclid's division lemma to show that the cube of any positive integer is in the form of 9q plus 1 and 9q plus 8, where q is an integer. So solution will be of this question. Let's any positive integer equal a and the value of a equal 3q plus 1 or 3q plus 2, because given in the question cube of a equal 9m plus 1 or 9m plus 8, then according to question at first we take a equal 3q, both side cube, then we find a cube equal 3q whole cube equal 27q cube, and we write the last step in the form of 9 multiply 3q cube. Okay, when we compare, put equation first, when we compare the last step with equation first, then we find compare with equation first, then a cube equal 9m and the value of m equal 3q cube. Okay, and the second we take a equal 3q plus 1, both side cube, then we find a cube equal 3q plus 1 whole cube. Okay, and the value of a plus b whole cube equal a cube plus b cube plus 3a square b plus 3ab square. Put the values a and b, then we find a cube equal 3q whole cube plus 1 whole cube plus 3 into 3q whole square into 1 plus 3 into 3q dot 1 square. Okay, simplify the step, then we find a cube equal 27q cube plus 1 plus square of 3 equal 9 and 9 3s are 27, q square plus 3 3s are 9 q, and the square of 1 equal 1. Then we find a cube equal, put common in 27q cube, 27q square plus 9q is 9, then 3q cube plus 3q square plus q plus 1, and compare with equation first. then a cube equal 9m plus 1 and the value of m equal 3q cube plus 3q square plus q. Okay, and last is value of integer equal 3q plus 2, both side cube. Then we find a cube equal 3q plus 2 whole cube, and the formula of 3q plus 2 whole cube is same, last integer 3q plus 1 whole cube. Okay, then the value of a cube equal 3q whole cube plus 2 whole cube plus 3 into 3q whole square dot 2 plus 3 into 3q dot 2 square. Okay, simplify the step, then we find a cube equal 27q cube plus 8 plus square of 3 equal 9, 9 3 is 27, 27 2 is 54, q square plus 3 3 is 9 and square of 2 equal 4, 9 4 is 36 q. Okay, compare with common 9, then we find 3q cube plus 6q square plus 4q plus 8. So compare with equation first, then we find a cube equal 9m plus 8 and the value of m equal 3q cube plus 6q square plus 4q. So we can write the cube of any positive integer in the form of 9m plus 1 and 9m plus 8. Okay, copy the question quickly. And this question is come 2 times in exam of 10th board exam. Okay, and third question is show that any positive odd integer number can be expressed as 6q plus 1 or 6q plus 3 or 6q plus 5 where q is a positive integer. Okay, question number 3, let's any positive integer equal a and a equal 6q plus 1, 6q plus 3 and 6q plus 5. Total value of a, first a equal 6q plus 1, second a equal 6q plus 3 and last a equal 6q plus 5. We know that a equal bq plus r by Euclid's lemma. Okay, and the value of r greater than equal 0 and less than b, then when we compare a equal bq plus r to a equal 6q plus 1, then we find value of b equal 6 and value of r greater than equal 0 and less than 6, then r equal 0, 1, 2, 3, 4, 5. Okay, and odd values of r equal 1, 3 and 5 given in question. Any positive odd integer, okay, then we put the value of r is odd numbers, so 1, 3 and 5. Then if r equal 1, then a equal 6q plus 1. If r equal 3, then a equal 6q plus 3. If r equal 5, then a equal 6q plus 5. So we can say when we add even number in even integer, then we find even, and when we add odd number in even integer, then we find odd integer. Okay, and last steps of question number 3 is we can write then we can write any positive integer in the form of 6q plus 1 do odd, 6q plus 3 and 6q plus 5. Copy the question.